Okay, this is the piece of paper you should have printed in front of you as we go through these notes. I'm not going to read it in its entirety, but I am going to give you a couple of key things that you will need to know from this sheet. Okay, Newton was all related to one goal. All he wanted to do was explain gravity. He realized that to explain gravity, he would first have to come up with a set of rules to explain forces in general. Okay, he said that a gravitational force exists between any two masses. Because of his third law, so this was back to Unit 1, when you fall on the Earth, it's pulling you down, and you're pulling the Earth up with just as much force. We don't see this because the Earth weighs so much more. It has so much more inertia than what we do. Okay, so I want you to think about teeny tiny little you, and you might want to draw this right beside your notes, and then big Earth. If you think about the forces, the force of you, and we say it comes from the middle, the force that the Earth pulls down on you is equal and opposite to the force that you pull up. So these should be the same. So you're pulling the Earth up. These should be the same length. Okay, so the forces are equal. So the force on the Earth is mass times acceleration, and the force on you is also mass times acceleration. Okay, let's think about this. Earth has a super, super big mass. Very, very, very big. So much bigger than you. You have a teeny tiny mass. Okay? So the acceleration is then going to be smaller. It's going to just need a little bit of acceleration. Okay? Meanwhile, if you have a very small mass, you're going to have a very large acceleration to make these two equal. Okay? So that is why we feel the acceleration, but the Earth, we can't really see it being accelerated up towards us. Okay? Next, it goes through and talks about weight and mass. The important thing is weight is the same thing as the force of gravity. So this Fg should really be F sub g, like a teeny tiny subscript. And that is equal to mass times g, and that was a formula on your formula sheet. Throughout this entire course, I'll probably say on your pink sheet or on your formula sheet. In class, I always print that formula sheet on pink, so that's what I'm talking about, okay? So if you ever hear me say pink sheet, it's the big formula sheet that you get for all exams you were given at the beginning of the course. Okay. Let's look at this question here. I have a 5-kilogram rock. Determine how much it weighs on Earth and on the moon. Okay, so we said weight is the same as the force of gravity, which is mass times gravity. So let's first look at Earth. Okay, so the force of gravity is mass, 5 kilograms, times g. This is a constant on your formula sheet, and it's 9.81 meters per second squared. Okay, a kilogram meter per second squared is the same as a Newton. We don't need direction for weight. Okay, the force of gravity is downwards. It's true, the acceleration due to gravity is downwards and this force is downwards, but I'm just talking about weight, and weight is not a vector. It's just that value. Okay, so when I calculate this, I got 49.05 newtons with sig figs. That is going to be 49.1 newtons. Okay, now let's look what's happening on the moon. Here we know our g value is 1.67. So force of gravity is the same as weight. On the moon is the mass. There's still 5 kilograms of rock. There's still 5 kilograms worth of atoms. And we're going to times this by g on the moon, which we said was 1.67 meters per second squared. Okay, multiplying this together, we're going to get newtons. Yes, that's probably downwards. Weight doesn't need that direction like a force or acceleration does. So kilogram meter per second squared is a newton. We calculated out with sig figs, I got 8.35. Okay, part B I already talked about a little bit. Determine its mass on Earth and on the moon. Mass is talking about how much stuff. It's still made of the same amount of stuff. Okay? The next page talks there's actually another question before I go to the next page. An object is accelerated at 3.24 meters per second squared by a 68 Newton force. Determine its inertial mass. Okay, so F equals ma is what we're going to use here. We have F, we have A, we want m by itself, so we're going to go F divided by A equals m. I divided both sides by A. Okay, I said my force was 68 newtons, and I'm dividing that by 3.24 meters per second squared. Well, a newton is simply a kilogram meter per second squared. Kilogram meter per second squared. Meter per second squared cancel out. Okay, I'm left just with kilograms, which is good because it asks me to find a mass. So now it's just calculator work. 68 divided by 3.24. I got 20.987 with 3 significant figures. That would be 21.0 kilograms. Okay. The next thing you're going to go through is gravitational field. Just the idea of what a field is. I start talking about Rice Krispies and even and social studies. One thing I'm going to note right here, 9.80, 9.80, I believe that our text where I got this resource, it did 9.80. Sometimes 9.81 is what your formula sheet will say. So just be aware, always use your formula sheet, but I use a textbook and I often steal questions from a resource that might use 9.8. So if you're ever just a little bit off in your questions, use them as a guideline, and that could be why. So this resource that I used for this handout used 9.8. And so just be aware, in physics, that happens sometimes. Okay, so you're going to read through this. There's something else we had to write down. Where was it? Okay, I want you to notice G equals the force of gravity over m. So just to make sure you know that's force G over m. That's a subscript there. Just fix that up to make sure it's very clear on yours. And then down here as you're reading, it'll say a relationship. G is proportional to, and the symbol used for proportional to is like a little fish, 1 over r squared. Okay, so that means that as the distance gets bigger, r is the distance from the center. As that distance gets bigger, g gets smaller. So if you think about that, the farther you are away from something, the less you are influenced by it. The biggest example that I would use for this is, why do you move away from home? You're farther away from your parents, so you're less influenced by them. You're less influenced by them asking, where are you going? What are you doing? How are you spending your money? Okay? And then we're going to go to the law of universal gravitation, which is coming up next. Okay, there's an assignment, some things to try here. And there are answers given for the numerical question 6 I'd like you to try. This one, I want you to think about what a balance is. So a balance means to find out what I weigh, what I do is I keep adding weights over here until it completely balances. If I don't add enough weight, this balance is going to, that would be if I added too much weight. If I didn't add enough weight, I would make this teeter-totter fall down. So really this question is saying, why am I going to get the same value if I use a balance? That's kind of the key word for this question. Okay, good luck.